Today we're going to talk about section 8.6, which is on solving rational equations. And we're going to look at doing this through a method called cross-multiplying. So we can use cross-multiplying to solve rational equations when each side of the equation is a single rational expression. Now we've used cross-multiplication numerous times in the past. So if we have a proportion, fraction on each side, we can set up the cross-multiplication. So we're going to start with cross-multiplying. So we're going to have 7 times 2x minus 10. And then we're going to also do the other side. So we're going to have 11 times x minus 2. So if we go ahead and do the math on this, we're going to have 14x minus 70 using the distributive property and 11x minus 22. And so now we have a linear equation which we're just going to solve like we've done hundreds of them before. So if we get all the variables on one side, we're going to have 3x over here. We add the 70 to both sides, we're going to get 48. We divide by 3, and 48 divided by 3 is 16. So we're going to end up with x equals 16. We're going to jump right down to the guided practice on those questions. So go ahead and try a couple of those. You can pause the video and then hit play when you are ready to resume. And here are the answers you get when you solve these using cross multiplication. Again, remember, check your solutions. You make sure to plug them back in, because sometimes we may still get extraneous solutions which are not truly solutions to the equations that we have. Now in this case, all of these solutions work for this problem. Now the next example we're going to look at is example 3. Now if we look at the difference here, now we have 2 fractions on one side of the equation and only 1 fraction on the other. Well, if we have 2 fractions on one side of the equation, we can no longer use cross multiplication. So what we're going to need to do is get a common denominator. So if we look at these, I can see that my common denominator is going to be 5x. So I'm going to get a common denominator between every one of my fractions. So in the first one, I needed to get to a 5x, so I needed to multiply by 5. So when we do that, we're going to take 15 times 5, which is going to give us 75. So this is going to be 75 over 5x. In my second fraction, I needed the x. We're going to multiply that. That's going to be a 4x. In the third fraction, I needed the 5, so that's going to be 35. So now, from here, we can do a couple of different things. But once we have a common denominator, essentially, they will just cancel out. If I get a common denominator between every one of these, they're going to be gone. Because what's going to happen is when I add those terms up, I'll have, when I cross multiply, I'm going to have 1 on each product, which then will divide out. So we can just simply write this as 75 plus 4x equals 35, and then solve for it. So we're going to get 4x equals negative 40, and x equals negative 10. And so our answer is D, negative 10. So jumping down to example 4, again, notice that we have a rational equation here. We have 3 fractions. Well, if there's nothing there under that one, it's just 1. So again, we're going to do the same thing. We're going to get a common denominator. And in this case, it's x times x plus 7. So I'm going to do that for all of my denominators. X times x plus 7. And I'm just going to write them under here. And just like we did in the last section, now we have to figure out what do we need for each fraction. So in the first one, I have an x plus 7. I need an x times x plus 7, so I just need the x there. So I need to multiply that by x. So we're going to have 12x. In the second one, well, I just have 1. I need all of that denominator, so it's going to be x times x plus 7. I need the whole thing there. And in the last one, I need the x plus 7. Okay. So here's essentially what we have. And once again, once I get a common denominator with all these, I can forget about them because now I've eliminated that. So what we're going to do is go through and do the math on it. So we're going to have 12x equals x squared plus 7x minus 12x. And then we also have to take 12 times 7. And so that's going to be negative 84. Now remember, this negative sign has to go through as we multiply that because it's subtracting that whole fraction. All right, so now we're going to set this equal to 0, simplify it. So we're going to have 7 and a negative 12 and another negative 12, which is going to give us negative 17x minus 84. All right, so now we have this set up as a quadratic equation. And so what we need to do is we need to try to figure out what are the factors that are going to go into here. So we're going to have x and x, and I think we're going to go 21 and 4. It's going to be a minus and a plus. So here, we're going to have x equals negative 4, and here x equals 21. So those are the two solutions that we will get for this problem. And once again, you should check them. So let's plug these in. So we put in a negative 4 everywhere there's an x. So we're going to have negative 4 plus 7, that's 3. 12 over 3 is 4. And then put in negative 4. So we're going to have negative 12 over negative 4, which is 3. 1 plus 3 is 4. That one will work. And then we're going to do the same thing with 21. 21 plus 20 or plus 7 is 28. So we have 12 28ths. And then that's going to equal 1 minus negative 12 21sts. And so if we put those on our calculator, you can get a common denominator if you want, but if we type it in on our calculator, 21 or 12 21sts is 0.57, so we're going to go 1 minus 0.57. It's about 0.43, and 12 divided by 28 is about 0.43, so that one works as well. So both of these are, in fact, solutions to that problem. Okay, so far, all of our solutions have been actual solutions, which is going to bring us to that next part, which we've talked about before, and those are extraneous solutions. And extraneous solutions, they occur when solving a rational equation. You may obtain solutions that are extraneous, so they're extras. Be sure to check for extraneous solutions by substituting back into the original problems that you looked at. So let's look at example 5. We're going to solve this one. And again, first thing we're going to do here is factor this, x minus 1, x plus 1. So now we have 3 fractions. Again, we're going to want a common denominator. So we're going to want a common denominator, and it is going to be x minus 1 times x plus 1. Okay, so I'm going to go ahead and write that down for every one of my fractions. And obviously that's all of it right there. So I have the 6. So in the first one, we need the x plus 1. So it's going to be 7 times x plus 1. In the second one, we need all of it. Okay, and once again, denominators are gone. Okay, don't need them anymore. So we go ahead and solve this. 7x plus 7 minus, and I'm just going to put this in parentheses right now. This is really going to be x squared minus 1 if we FOIL those. So if I then multiply by the 5, it's going to be 5x squared minus 1 equals 6. Well, so now I have to take this negative sign through there, so it's going to be 7x plus 7 minus 5x squared plus 1 equals 6. Get everything on one side. And since my x squared term is negative on the left, I'm going to move everything to the right side. Just because I always like to have a positive x squared term. So that's going to go over there. We're going to have a minus 7x. And we're going to subtract. We have 8. With this, that's 8. So 6 minus 8 is negative 2. So now we have a problem that looks like this. So 5x and x are the factors there. Has to be 2 and 1. So there's going to be 2. Here's going to be 1. Oh, hold on a second. Oh, found a mistake. When we did this distributive property here, this should be on a 5. So that's a minus 5. So this should switch to a plus 5 right here. All right, so we have 12. So this is going to be, we have 12 there, so it's going to be a negative 6. So now let's try that again. See if we can factor this. So 5x and x. We're going to go 2 and 3 minus and plus. Does that work? Well, that gives us negative 10x on the outsides, 3x on the inside. So, all right. So there we go. There is our factors. Well, if we solve it, we're really going to get x equals negative 3/5 here and x equals 2 here. So what we have to do is take those numbers now and plug them back in to your original equations. So, and when we do plug those in this case, we'll once again find that they both do work. Okay, so both of these are solutions to that original problem if you plug them back in. Okay, so make sure you plug them into your original equation to check to see if they are solutions or if in fact they are extraneous. So to finish up the lesson here, we have a few guided practice questions. There are 6 of them here. I'm going to go ahead and do all of them. You can do a couple of them if you would like. You don't need to do all of them, but go ahead and pause the video until you are ready to resume. And here are the answers to the guided practice questions. Notice in 5 and 6, we both just got a common denominator. And then simplify these linear equations. Same thing with number 7 and 8. They both ended up being linear. We got down to question number 9. It became quadratic. We solved them. Again, we plugged them both back in. Both of these work. However, in number 10, we got to a solution of x equals 2. But notice when we plug it in to here, we have 2 minus 2, which is 0. And you cannot have 0 in the denominator. Therefore, 2 is not one of the solutions. And so in this problem, there is no solution to that. So that's the material that we're going to cover out of section 8.6. And we're solving rational equations. And basically we looked at 2 things. If we have one fraction on each side, we can simply cross multiply. If we have more than one fraction on one side of the equation, we have to get a common denominator like we did in these last 6 examples. Then once we get that common denominator, those will cancel out and we just take the numerators and solve that equation. So here is your homework assignment for section 8.6.